Business Calculus, Topic 6.1. Problem number 5. We want to integrate the problem 2x plus 1 all over e to the 3x power. Well, first we want to turn this from a quotient to all multiplication. So this will be the integral of quantity 2x plus 1 times e to the 3x power, and then dx. Okay. Now, because I have basically two functions here, we're going to attempt to solve this by integration by parts. So one of the functions I want to treat as a derivative, take derivatives of the other. I want to take integrals of it. For the derivative, I want to use my 2x plus 1. And for my antiderivatives, or integrals, I want to use my e to the 3x power. Okay, now start taking derivatives of the 2x plus 1, and I'll keep doing the iterations until I get down to 0. So the derivative here is 2, and the derivative of 2 is 0. Okay, so that's finished. Now, to take an antiderivative of e to the u power, we're going to need a du. Or should I say a du over dx. The derivative of this u right here will be 3. Oh, sorry, I'm leaving off a negative here because that came from the denominator, so it'll be a negative there. This is a negative 3. Okay, now that's correct. Alright, so the derivative here of the u part will be negative 3, so the reciprocal will be on the next part. So the antiderivative of e to the u is again e to the u, and then times the reciprocal of the derivative, which is a negative 1/3. Then the antiderivative e to the u again is also e to the u, and the derivative of u is negative 3. And so when we take the reciprocal of this, we'll get another negative 1/3, which gives us now positive 1/9. Okay, so let's put this all together. These two will come together, and that'll give us our 2x plus 1 times negative 1/3 e to the negative 3x power. And the combination of these two, plus minus plus, okay, now this will be a negative 2 together with the 1/9 and the e to the negative 1/3. So negative 2 over 9, and let's see, e to the negative 1/3. E to the 3x. Negative 3x. Now, the final part is the integral of this combination. We multiply 0 times this term here, we'll get 0. But the integration of 0 gives us a constant, so this will be plus c. Let's begin to clean all this up. I'm going to take common factors of e to the negative 3x power out. And we'll also take out the least common denominator, which will be 9. So let's take the 9 out. And we'll also take out the negative. So we take out all three of these terms, all of these. To make this a 9, we need to multiply this by 3. So this will be 3 times 2x plus 1. We're taking the negative, the 9, and the e to the negative 3x power, leaving behind the positive 2 here, and then plus c. Now, let's begin to clean this up a little bit. This will be negative, and our numerator, when we distribute, this will be a 6x plus 3, and then plus 2. In the denominator, we're going to have a 9, and an e, because that's a negative exponent, so it means the e is a denominator now. And we have positive 3x, and plus c. And now I can add the 3 and the 2. So the final answer will be negative 6x plus 5 all over 9 e to the 3x power plus c. Okay. Now, we want to find the antiderivative of a natural log of x. Well, think of this as actually two functions. One of the functions will be 1. The other function will be the natural log of x. So, for my derivative, I want to put the natural log of x there as a function. And as my integral function, I'll put the 1 there. So there. Now, the antiderivative of natural log of x, sorry, the derivative of natural log of x is going to be 1 over x. The antiderivative of 1 is going to be x. All right, we'll stop here and have our plus and our minus. So these two combine for our first product, x times the natural log of x. X times the natural log of x is there. And these two will be my integral. So the negative is my integral. And what is 1 over x times x? Well, 1 over x times x is going to be 1. So this is actually going to be the integral of 1. Now, the antiderivative of 1 is going to be x. So we'll have x times the natural log of x minus x, and then plus c. And this is our final answer.